CQRS and EventSourcing with Greg Young.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. This podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. They are hiring both architects and .NET engineers who'd like a path to become an architect. So you can go to clearmeasure.com/careers for that. And our guest today on the show is Greg Young. Greg is an independent consultant and serial entrepreneur. He has a ton of years of experience in computer science, from embedded operating systems to business systems, and brings a pragmatic and oftentimes unusual viewpoint to discussions. He coined the term CQRS, which stands for Query Responsibility Segregation, and it was instantly picked up by the community who've elaborated upon it ever since. He's a frequent contributor to all kinds of mediums and conferences like InfoQ, Skills Matter, and he's a well-known speaker also at international conferences all over the place. He's done a ton of speaking over time, ton of training. And Greg, welcome to the show. How are you, sir?
Hey, don't forget, I also founded a large conference.
There you go. Well, tell us about that one real quick so we don't miss it.
Oh, so some years ago, I founded a conference called Build Stuff, which I have to say was not actually the first name of the conference.
Okay.
The first year that we ran it, we actually named it We Actually Build Stuff.
Okay. You had to shorten it a little bit?
Well, it was also that some people might take slight offense to the we actually build stuff part.
Gotcha. Well, I think there's a ton of listeners who have heard you speak in some form or fashion or have followed you, and but for those who haven't, of course, they're encouraged to look you up and look up all your writings on CQRS. But how did it end up being your focus here, and kind of what was your background or high points that led you to what you're working on today?
Okay, so this is actually kind of weird. So early in my career, I was actually poached out of university to come work for a company, and I was building gambling systems. In particular, I was building lottery and horse racing systems.
Okay.
Oddly, when you think about like a lottery or a horse racing system, EventSourcing kind of comes right to your mind, doesn't it? I've got bets coming in. I need to write down the bets.
Mm-hmm. What actually happened? Yeah.
Then I need to calculate afterwards, when we know who won, who gets how much money. And then people will cash their bets. And, well, we should probably write those down as transactions too. But then I start seeing it in a lot of other systems. Like, there's nothing new about EventSourcing. I mean, this software was built in the damn 80s. The most interesting thing was when we started applying this same idea to other domains. So what if we were to look at a court system like this, as opposed to looking at it as a third normal form database model?
So you kind of stumbled into this early on in your career and started figuring this out.
Well, and it was taking the same ideas, which are old. They're very, very old.
Okay.
Like most of the guys I've worked with there are like literally retiring now.
Oh, wow.
But what if we applied that same idea to something that would be more of a typical system?
Okay.
And there were many, many systems that were built that way back in the days. You know, they were running on VMS, they were running on varying mainframes. But what was interesting was when you started applying them to other systems, it actually worked really, really, really well.
So before we get too far, I think we should define it. There's probably a lot of listeners out there who's like, okay, I've heard these terms. What the heck is it? And we got two
So,
names. We got CQRS, we got event sourcing, and like what the heck's the difference and all that.
CQRS is really, really simple. It's a trivial idea. It basically says we have reads and we have writes.
Okay.
So a write does not return anything. A read is anything that returns you something.
Okay. And how does that different from what? Because anybody that uses a database system would say, well, yeah, I have a select statement and I have an insert statement. Right?
But things that can return you something are not allowed to mutate state. So if I'm returning you something, this is immutable, it is thread safe, it is all of these wonderful things. My writes must come through a single path. It's not I can go update something and then return you the value. It must be that my reads are pure.
Okay. So with the focus on making them pure, what was the industry problem that was observed to say, you know what, this isn't so good. We need to keep these pure. We need to keep these separate.
How many bugs have you found where somebody was reading some data from a database and then we're changing it at the same time?
Oh, yeah, fair enough. Fair enough.
That was one of the main focuses behind things was I should be able to do a read, and my read should basically be just transforming data out, and it either works or it doesn't. I should be able to do 5 reads concurrently, and it should not affect any of them by doing them at the same time.
Makes sense.
It makes it much easier to rationalize about things.
Now, in order to implement that, are certain other patterns, do they just fall into place? Or like, for instance, the programmers who are just saying, file new project and double click on a button, and then they write some code that's using, entity framework that goes directly against the database. Would they need to necessarily implement some type of separation? What does it typically look like?
Okay, so with CQRS, at its very base level, the simplest. So typically we just do this at the service level. So, or I should say, this is the starting point that we kind of do it.
Yeah.
So all I've done at this point is I've taken my reads and put them onto one service, and I've taken my writes and put them onto another service. These two services, they interact independently of each other. It's a really simple idea.
Mm-hmm.
Now, I'm pretty sure you've had a scalability problem at some point in your career.
Never. Nope. Just kidding.
That system you were attempting to scale, I'm willing to bet that the scalability problem was on reads, not on writes.
Well, yeah, there are a whole lot more reads than there are writes when humans are the generators of the transactions.
For 90% of systems.
Yeah.
There are some, and I've worked in quite a few, where we had many, many more writes than we had reads. I can give you a great example of this if you want one.
Yeah.
The stock market.
Tons of generated computer trades.
Well, we're getting thousands and thousands of things that have happened per second, and you're looking at basically a small summary of things that have happened.
Yeah, that's true. There's also I've worked extensively with the auction system and the concept of a proxy bid up to a maximum amount. When you authorize a computer to kind of, outbid on your behalf, that also generates a bunch of transactions.
An auction system like that, does it actually increment the bids one by one competing with each other? Or does it look at the two bids and go, you went up to $28, you only went to $27, so we're going to put it at $28?
Yeah, both designs, but yeah, they're very different as far as how it behaves.
Well, you can imagine that could cause some problems if we were talking about bidding on something like a RV.
Mm-hmm.
And it's currently at $2, but I've set my maximum to $88,000.
Right.
And you come in and say, no, I'm willing to pay $89,000, and it incremented by $1 per bid.
That's right. Yeah. A whole bunch of trash transactions.
Although they would be traceable.
So how does CQRS, before we get into that, okay, we define CQRS. How would you define event store?
Event store or event sourcing?
Oh, I'm sorry. Event sourcing. Yeah. And what are the terms and how should we be using them?
So event sourcing is basically just me saying that I am going to Instead of keeping, let's say, a third normal form database or something like that, I am just going to record facts that have exist. You tell me, cook this food. I say food was cooked.
Okay.
And I include what the ingredients were, that sort of thing. And I just store the event that this has occurred.
Okay.
You say, I would like to change the name of this customer. I say, customer name changed. Now, don't get me wrong. I might tell you to piss off. I'm not going to allow you to change your name. But providing I'm going to allow it, I then say that this is an event which has occurred. You decided to change a customer's name, and the customer's name was changed. Now, we can interpret this in millions of different ways. We can have 27 different things that all interpret the concept of a customer's name change differently. And this is the real value behind everything.
And a lot of programs would say, well, that just is a update customer set name to.
But there's a problem there. You just lost information.
The previous name.
Correct. How much was that worth?
Yeah, who knows?
Well, and you're saying today, like, we don't really care. Okay, there's a new piece of legislation that's passed 3 years from now, which...
Sure, yeah.
Suddenly, that piece of information might actually become valuable. And now you're going to kick yourself because you lost it.
Yeah, previous addresses are always valuable, seems like.
Well, but the thing is, we don't know for any given piece of information whether or not this will ever be valuable in the future. This is the fun part.
Yeah.
It basically brings you to the point of, well, just keep everything.
Okay.
I have no idea how to value this. And I can tell you that it's going to cost us a little bit of disk space. So we'll just keep everything.
So how does that look? Because programmers are educated on, database structure, and that is, you're looking at it and you're looking at the current truth of the data you track. So how does this look in database technologies?
Okay, so if we go look at Event Store, what you basically have is a transactional log, and there's operations you can do on a transactional log. That transactional log will guarantee you serializability. So when you go to write, there is a guaranteed ordering to them, and you'll be able to read them in the same order as they were written infinitely.
Okay, got it.
So if you replay like 5 times in a row, you'll have deterministic results off of 5 times in a row.
Is this transaction log, is it one new, say, table, or is it a transaction table per regular table in your schema? How does it typically look? Or is there?
No, in Event Store, it's literally a transactional log.
Okay, so
it's made up of files.
Okay. So I'm guessing technically you could be as simple as files. Do people ever make document databases or relational tables to store the transaction log, or what do you typically see?
Oh, people have done all sorts of bizarre things, and they run into all kinds of interesting problems, having assumed things about their technology. But you can build one on top of a simple SQL database. I'm going to build a table. It's called transactions, and now I'm basically going to ensure serialization down to this table, and it's just an appending table.
Okay. So does it just have a blob field of some sort?
That's one way that you could do it. Some of the new databases, they handle things like JSON as well.
Okay. So some sort of serialized column type.
Correct.
Okay.
And the only thing we ever do into this is we insert or delete. There is no concept of an update.
Yeah, because that wouldn't make sense. I'm thinking of accounting systems. Like in my checking account, there's never the concept of going back and modifying yesterday's transaction.
Exactly. It's if something was screwed up yesterday, we put in something today to undo the screwed up thing from yesterday and to correct it.
Yeah.
The really cool thing about this, though, is let's say we're now 2 years later and we go, how many things did we screw up over that? Well, we can go back and look at the transaction table to see how many of those actually occurred.
I'm also thinking of Git. If I revert to yesterday's commit because I screwed something up, I don't actually, I could scrape it, but I typically just commit something new that's the opposite of what was before.
Yes. And Git is another great example of something and Git is not purely event sourced, but if you squint at it the right way, it's event sourced.
Yeah, you have to ignore some of the commands, right? Ignore some of the capabilities.
Yeah, there's some odd things that you can do with Git, like editing old commits, but
Yeah. I don't like those features because they, anyway, detour. Okay, so you have this transaction log, and you can replay it to get the current state. Do you typically also have your relational schema in addition to it?
yes, that sits next to it in a read model. But the relational schema, as an example, is not going to be the same relational schema because you're not using it as your primary writing source. You're using it essentially only to build reports off of. That's where you get the data you show on the screen to the user.
Okay.
So why would I put it in a third normal form model? I instead put it in a first normal form model.
Well, I suppose the real answer is because most programmers with a formal education are taught database normalization to third and Boyce Codd normal form. Maybe that's why, because we've taught them to do it that way.
We have, but with an event source system, I'm probably going to put it into a first normal form. Okay. Or what I like to call it is sometimes like a rather informal first normal form. We're just kind of putting things here. They're denormalized, but we're not militant about it.
Yeah. We have good single types, but we're going to have the same piece of data in multiple tables.
Yes, and there's some cases where you do actually want to normalize. Some examples of this might be if I had a graph and the graph had a huge number of links, I might prefer to not denormalize that and to leave it in the normalized structure. Oh, don't get me wrong. I'd love to have, 2.7 billion nodes through it, but
right. Okay. All right. So what does it look like? Someone has a checkout button, and behind their button, they got some code that eventually, used to, just do a couple insert statements, maybe some update statements. What does it do instead with event sourcing?
So what it's going to say, and checkout's actually a little bit of an odd example here because you also have some other things that are going to need to happen, like taking payments, and we have a process associated with this.
All right, you got it. Well,
but let's just take something similar.
Yeah,
it's basically going to say, please check out this order.
Mm-hmm.
Now that's going to come to the code. The code is going to look at everything inside the order. Does this seem reasonable right now? No. Piss off. Okay. Everything seems quite reasonable in this. Order accepted.
Mm-hmm.
Now, this does not necessarily mean I've billed your credit card. It does not necessarily mean I've done all of these things. But now I've said this is an order. You have told me you want to check out. We now have an order. So the simplest thing here would be that we actually charged your credit card when we did this.
Mm-hmm.
Now, simplest, not this is the right way of doing it.
Right. Not the most scalable.
So now I also have your credit card payment. So basically my order accepted here is now going to get listened to by something else. Because I'm guessing you want your order fulfilled as well.
That'd be nice.
Hey, we don't expect too much out of this company.
Right.
They might be like FedEx. You never know.
Like 1990s e-commerce. You just didn't know.
But at the same time, when we have an order accepted, maybe the accounting system is interesting in that. How cool would it be if the accounting system was giving real-time reports about our profit and loss throughout the day?
Now, it sounds like you're linking asynchronous processing to event sourcing.
Well, events are, by their nature, asynchronous. But once we have these facts which are occurring, so we're storing things as facts, not as I updated a database table in some way.
Yeah.
We can end up with subscription networks of these facts. We can end up with automation that starts occurring on top of this. This is a well-known form of integration as well. And all sorts of cool things start happening. The really cool thing about them is that they don't happen Monday night at 2:00 in the morning when this batch job runs. They happen in near real time.
Yeah.
And we can control that near real time.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
So I'm hearing a lot of listeners who are trying to picture in their head, okay, I've saved this to the transaction log. Well, when the mouse comes up off the button and the screen updates it, at that point, what has actually happened and what is still to happen?
So we're now going to get into a very, very fun pattern. Well, two patterns. So one, you can never know, because maybe I just changed the software 10 seconds ago.
Okay.
It no longer works the way it worked yesterday. 10 seconds ago, the process is completely changed.
Because of a deployment?
Yeah.
Okay.
But there's a pattern that we can use here, which is known as correlation and causation ID. So it's a really simple pattern. It's basically if you receive a message and you are going to put out a message because of that message, you copy that message's correlation ID. Your causation ID is the message ID of the message that you're responding to.
Okay.
Okay, so now you went and clicked this button and a bunch of stuff starts happening. I can show you a graph of how all those things are related to each other. So you did this, which caused this, which caused this, which caused this. And over here, this thing also caused this other thing down here. And here's a graph of everything that actually occurred.
Okay, so which one of those IDs would typically the original order confirmation number be?
Neither.
Okay.
It's just two arbitrary IDs put onto it.
Sounds like a GUID.
A GUID is a wonderful way of doing it. And come on, in many languages, we like calling them UUIDs.
Okay.
But it's basically just saying that this is a group of messages that are all related to each other.
Mm-hmm.
And it allows you to build up a graph showing this is how they're related.
So if the causation ID is the message prior, then what is the correlation ID?
Okay, so the correlation ID comes all the way off the very, very first message.
Okay.
So you just copy the correlation ID of whatever message you receive. Your causation ID is the message ID of the message that you're responding to.
Okay. So let's simplify it for the listeners. Let's say that the only thing that has to happen is charging a credit card, and that's it. And we say, okay, I don't want to call out to the credit card gateway while someone's waiting for the button click to come back.
Yeah.
So
okay, so we're gonna have you send me a message. Charge credit card.
Mm-hmm.
You gave me a correlation ID of 13, and you have no causation ID. It's -1 because nothing caused you. It was just like a user clicking something.
Okay.
Okay, so now I get that, and I'm like, ooh, I should charge credit card. So I say, okay, charge credit card. We got an approval. Credit card charge successful.
New transaction log item.
Correct.
Okay.
And I'm going to say that my correlation ID is 13 because that's what your correlation ID was. And my causation ID was, I forget what we said your ID was, 7. It's your thing that told me to charge the credit card that caused me to say, well, yeah, I charged the credit card.
Okay.
And then based on me having charged the credit card, there might be something else which occurs in the system.
Mm-hmm.
Maybe it moves it to the shipping section of the warehouse. They would again then do the same thing. They would copy the correlation ID from mine, and their causation ID would be that I said it was paid. That's why they moved it to the shipping area. So what you end up getting is graphs of these.
Does it push or almost force you into 99% asynchronous processing when you go this direction? So I'm thinking if you
this is almost certainly asynchronous.
Yeah, because if you sent something to shipping only after you charge somebody's card, then if the gateway or the card failed, Now you got two things, one of which can't really be rolled back.
Well, we might also have a security auditing service, which also listens to credit cards being charged.
Yeah.
And it's making some decisions of, well, are we sure we're really interested in this? We might want to do a little bit more.
There's an interesting architectural thing that happens. You tell me if I'm wrong, is if something needs to happen after the credit card is charged and you publish an event, you flipped the dependencies where the other people that need to do something, or the other code that needs to do something as credit card is charged, it becomes their responsibility to listen for that happening and trigger themselves, versus the code that did the credit card charging's responsibilities to know and invoke that action.
Well, and this is one of the big differences when you start getting into integration scenarios, is that my team does not care who listens to our events.
Mm-hmm.
We represent, these are the events that happen in our system, and this is our contract. Do 3 other teams listen to these and they do some varying things with them, or is it 122? Not my problem.
Yeah, whoever has access to that event stream.
Right. And I provide this event stream to you, and I provide a versioning structure of this event stream to you. Like I say, I'm not just going to completely randomly change this at varying points in time, or that'd be really odd if I started doing that in a big company.
Right. We just used another term we got to define: event stream.
Oh, it's just a stream of events. It's an ordered series of events that are coming over.
Okay, so if somebody's in the .NET ecosystem, they're running on Azure, what technology would be associated with that stream of events tips?
Well, a
commonly?
event store would be one solution. A message queue would be another.
Okay.
A good way of thinking about it in .NET is actually just an IEnumerable of event, where event is a marker interface.
If it's in process, if it's in the same memory space.
Yeah.
Okay. So out of process, any kind of durable queue.
Yeah. So we need something that we're going to like serialize it to. Yeah. I'm guessing. I mean, don't get me wrong. We can do it just in memory, but if we're doing it in memory, we kind of have a problem with power going out.
Right. Yeah. Okay. So for this, durable storage of everything, including every event, is almost mandatory, right?
Well, when you're event sourcing, your events are your concept of truth. So if we were to randomly lose them, this would not turn out very well for us.
Right. Yeah, I keep coming back to the accounting systems. It's like all of them have perfected this model.
Yeah, we went through and we issued some checks to these people, but we just forgot about it.
Right.
It's okay. It's no big deal.
The server rebooted. Okay.
Luckily, the physical checks don't actually exist, and they'll never be cached.
So, going back to CQRS, is it inherently related to event sourcing, or did they just go well together? What's the relationship in your mind?
Okay, so event sourcing is its own concept, and it's really where you'll find most of your power.
Okay.
But if you're event sourcing, then CQRS just basically becomes like something natural. I mean, are you going to query your event log? So, like, if I ask for the balance of your account, are you going to replay the 9,000 transactions on your bank account to come up with the balance?
Seemingly no. You just have it read.
I mean, you could do it.
Yeah,
you could do it. It probably wouldn't be the most efficient way of doing things.
Right.
Instead, what I could do is I could have another database sitting next to that log, which then kept a table with all the accounts and their current balances. And it's just natural. Literally, CQRS just arises from the fact that you're doing event sourcing.
I think of the Kimball method for data warehousing, for star schemas and all that. That kind of flows naturally at this point too. If your regular read model is somewhat denormalized, then that's not a stretch just to jump to fact tables, it would seem.
Correct. And it's very common that my read models, they're in nothing even vaguely resembling third normal form.
Mm-hmm.
A star schema would be a great example of one that I might want to bring up. But there's another benefit here.
Okay.
Why are you thinking about having one read model?
So,
okay, you've worked a lot with SQL Server. I know that.
Oh, yeah.
Okay, so what I'd like to do is some full text indexing. SQL Server is obviously the best tool on the planet for this. Or would you rather use one of the many other tools that can do full text indexing in order to do those queries off of it?
I see. Okay, so you automatically get database technology portability because there's nothing tying you to consistency.
I can run 3 different databases next to each other,
Yeah.
each running parts of my read model.
And I guess they'd all be less than a second in sync with each other, wouldn't they?
Correct. And let's imagine that we had a really, really big document that was coming through. It's a really complex thing. Let's say like an incident report for police. Where this would be like to query it all out of a database, we're talking about like 25 tables that all need to be joined in varying ways to get everything out.
Mm-hmm.
Or I can just put it in a document database as XML.
Because it all goes together.
Well, and we know that the way we want to query it is I want the entire document. So this is one of the main benefits in terms of dealing with the read models is that I can choose different read models for different types of queries. Another great example of this would be you have a graph problem. Wouldn't actually using a graph database on it be fun as opposed to trying to do it in SQL Server?
Yeah. Yeah. Well, I don't think that this interview can possibly do this topic justice, but as we kind of get to the end of our time, you've been doing this for a long time. You've been teaching it, explaining it. As we close up, how has your method of explaining these concepts changed over time?
Oh boy, it's changed a lot. So it's one of those things where when you teach something, you both get a better understanding of the thing that you're teaching and you get a better understanding of how to teach it to somebody.
Mm-hmm.
If that kind of makes sense.
Yeah. Learn by teaching.
Yeah, it's kind of bizarre. Today, I'm fairly standardized on how I explain things. I mean, I make changes, but they're relatively small and relatively rare. But for a long time, I was all over the place. You converge upon a way of teaching it.
So just in your explanation today, it seems like you don't really care much about the other patterns that go into it as like the generic, transaction store, just have a list of transactions in some way versus explicitly, no, use technology A and use this way to save them and this way to retrieve them and all that.
Absolutely. It's not about the implementation. It's about the idea.
Yeah.
And the idea can be implemented in literally thousands of different ways. And between those thousands of different ways, there's going to be a certain set of benefits and drawbacks that occur across all of them. It's a different way of modeling things.
Okay. Now, some patterns have kind of been implemented, and there's various open source products or commercial products that go with it. Are there any such libraries or tools, free or commercial that you tend to, use from time to time or all the time and you like?
Well, obviously, I like EventStore.
Yep.
Most of frameworks I dislike, even the ones that have been built on top of EventStore.
Okay.
Mostly because in many of those cases, I don't find the value of the framework. It's going to take me longer to learn how to use the framework than it's going to take me to just write the code that I actually need.
Mm-hmm.
So it's like, okay, I'm going to be writing events. I need to write them to EventStore. They need to be in JSON. And I want to put on the time, the date. I want to associate the user to it, all in metadata. Okay, how long is it going to take me to figure out how to do this with your framework versus me just going and writing the code for that? Because that's all of like 27 lines of code.
Yeah. Well, let's make sure to put in a plug for EventStore and kind of what does it do for you? And for a programmer out there saying, well, why should I use EventStore? Can't I just, implement themselves? Give us the pitch.
Well, you can go off and build your own event store and it may work.
Mm-hmm.
What happens when you get to 1,000 transactions per second? Oh, the little thing you built up on MySQL in 45 minutes isn't turning out very well in that case.
Mm.
Well, oddly, we've thought about this a bit.
Okay.
Literally on my laptop, I can get event store up to about 30,000 events per second.
Nice.
What about reading out of your event store and dealing with subscriptions, things like that? Oh, wait, you didn't think about that? Well, that's a bit complicated. Another example of this, what if you wanted to do something like have 3 workers competing on events that came out of your event store? Well, this is starting to sound less than trivial. I guess maybe what you can do is put RabbitMQ next to your event store. You read the events out of your event store, put them into RabbitMQ, and then they subscribe to RabbitMQ. Okay, this is starting to get a bit complicated.
Right.
By the way, how do you scale that? These things are all just built into Event Store.
And so as we close up, I want to kind of tell people, we kind of just launched into it, what the heck Event Store is, how they can get it, how they can use it.
Well, the main place to start is eventstore.org. And you don't even want to know how hard it was for us to get that domain name.
Hey, but you got it.
We did get it, but it took years.
Mm-hmm.
Literally years. There's a whole bunch of documentation up there. There's videos, things like that, explaining things. Overall, the APIs in terms of interacting with it are relatively small. It's not like a lot of services where you get in and it's like, oh my God, I've got 800 different methods of interacting with this thing. It's like, well, you can write some events, you can read some events. There's a couple different ways of reading events.
Okay. We'll make sure to include that link in the show notes. And we've got so many links already because you've done so much speaking and writing, and the ideas and your name are cited in Microsoft documentation. Martin Fowler's credited you with his understanding of the topics. But for the programmers who are really intrigued and they just want to dig in, besides Event Store, is there anywhere we should point them to as a go here first?
Well, for anything with Event Store, there's a ton of stuff on the Event Store website that will basically branch them off into other places. And for EventSourcing, there are some videos online, like if they Google Greg Young videos.
Mm-hmm.
I even have like a 3-day class online that they can go sign up for.
Okay.
And if they watch my Twitter, I regularly put up like sales, things like that on it.
Mm-hmm.
If anyone is listening to this and they are from, as an example, a third world country, contact me. I will sell it to you for $1.
Okay. We'll make sure to put your email address in the show notes as well. Awesome. Very good. Very good. Well, Greg, hey, thanks for coming on the show, talking to us about CQRS and event sourcing. A lot of information to pack in. Can't begin to do it justice. Big topic. So it's good that you have lots of other recordings and training and whatnot. But I appreciate you coming on.
Great sitting here speaking with you. And I hope you have a good rest of your day.
Oh, thank you. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.